Have you ever wished that you could just talk to your app's documentation? Not scroll, not search, just ask. What if your app could actually answer, pulling the best responses straight from the docs, issues, and discussions? Let me show you something cool. This is starguide. It's a chat interface that understands the ins and outs of Serverpod and Flutter. It pulls data from the official documentation, GitHub issues, and real-world examples. You ask a question, and it answers like a pro. In this talk, I will show you exactly how we built it. Hi, I'm Victor. I used to work on the Flutter team, and now I'm the founder of Serverpod. Serverpod is the ultimate backend for Flutter. It's an open source, scalable backend written entirely in Dart for the Flutter ecosystem. If you're building apps in Flutter, Serverpod lets you stay in Dart all the way, on both the client and the server. No more switching between languages. You get type safety, code generation, and real-time communication out of the box. Today, we'll explore how Serverpod makes it easy to integrate with powerful AI models like Gemini, how you can build your own RAG pipeline, and how to stream responses from an LLM to your Flutter UI in real time. Let's dive in. So, what exactly is Serverpod? Think of it as a full-featured backend framework designed specifically for Flutter developers. Instead of switching to Node.js or Go or Python, Serverpod lets you build everything in Dart. You get all the essentials: type-safe APIs with automatic serialization, built-in support for talking with the database, authentication that is easy to set up. You can run background tasks and schedule jobs. Most importantly for this talk, work with real-time communication using streaming. And because it's written in Dart, your development feels seamless. The tooling is familiar, the syntax is consistent, and the integration with Flutter is incredibly smooth. But here's the best part. Serverpod generates your client APIs automatically. So when you write a method on the server, you can call it from Flutter just like it was a local method. Let's say we have a method on the server that calls an AI model. You just call that method from your Flutter app like any other Dart function. No need to set up HTTP, no manual decoding of JSON, no boilerplate code. And when it comes to real-time features like streaming responses from an LLM, Serverpod makes that just as easy. In short, Serverpod is the glue that makes full-stack Dart not just possible, but super productive. Let's talk about Retrieval Augmented Generation, or RAG. Have you ever wondered how large language models can answer questions about things that they never explicitly trained on? How do they know what's in your documentation, your help desk tickets, or your GitHub issues? The truth is, they don't. Not on their own. Out of the box, language models like Gemini or GPT don't know anything that's happened since the last training cycle. If you want them to respond with up-to-date, specific, or domain-aware information, you need to give them access to your data. And that's where RAG comes in. RAG is a technique that lets us feed external knowledge to an LLM in real time. It's like giving the model a cheat sheet. Instead of relying only on what it was trained on, we retrieve relevant documents from a knowledge base and pass them along as part of the prompt. Let's break that down. First, you have a collection of content, documentation, issue threads, support articles, whatever your app needs to know about. We split this content into smaller chunks. These chunks are then turned into vectors, mathematical representations of meaning, using something called an embedding model. Once we have those vectors, we store them in a vector database. This is a special kind of database optimized for searching based on similarity, not just keywords. When a user asks a question, we can run that question through the same embedding model to get a vector for it. Then we look up the most similar content chunks in our vector database. We grab those top results, package them up with our user's original question, and send everything to the LLM as part of a single prompt. The result? The model can now generate an answer that's grounded in the actual data. It's still doing the heavy lifting, understanding, summarizing, and responding, but it's using the context you provided, not just that it learned during pre-training. So instead of hallucinating or guessing, it gives you something useful, something real. That's the core idea of RAG, augmenting the model's generation with retrieval. And it turns general purpose AI into a domain expert instantly. Let's zoom in on a key part of RAG, embeddings. Have you ever thought about how we can turn words into numbers? And why would we want to? Embeddings are the secret sauce that makes this work. They're how we represent meaning in a way that the machines can understand. Here's the idea. When you take a piece of text, like a sentence or a paragraph, you can feed it into a special model that transforms it into a long list of numbers. That list is called a vector. But it's not just any random list of numbers. It's designed so that similar ideas end up with similar vectors. If two chunks of text talk about the same thing, their vectors will be close together in a high-dimensional space. It's kind of like plotting words on a map. Words and phrases that mean similar things will cluster near each other. The word server might end up close to backend, but far away from cupcake. This is incredibly powerful because once we've turned everything into vectors, we can search for meaning, not just keywords. We can take a user's question, embed it, and then search for the most similar chunks of content in our database. That's how we find the right context to send to the LLM. And here's the cool part. It doesn't matter if the words don't match exactly. If the question is, how do I secure my API? And the documentation says, authentication and authorization for endpoints, embeddings will still link them together because the model understands the underlying concepts, not just the surface text. Embeddings unlock semantic search. They let us build systems that reason about language instead of just matching strings. So, if you're building with RAG, embeddings are what connect the user's intent to the knowledge in your system. And once you see how they work, it's hard to unsee it. You start to realize that this is what makes AI truly useful. Now, let's put this into practice and see how we can build something like starguide. To keep things to the point, I'm going to focus mostly on the server side of things for this talk. Also, there are plenty of talks and documentation on how to set up your Serverpod project, so I'm not going to cover that today. Spoiler alert, it's super easy. Instead, we're focusing more on the actual code we need to write to make this happen. In addition to Serverpod, we're going to use the Gemini APIs to create vector embeddings and responses to queries to starguide. To make this work, we need to cover a few key aspects. First, we need to get the relevant information and documents into the database and create embeddings for them. For Serverpod, our documentation is in a GitHub repository as Markdown. Markdown is great for LLMs. We use GitHub's API to load the documents one by one. Serverpod has a really cool feature called future calls. It allows us to execute tasks server-side at a specific time or after a delay. This is perfect for something like starguide, as it allows us to invoke a method at a time interval to update the database in case the documentation is updated. In our future call, we will query the GitHub API to list the documentation pages and load them. To get the best results, we want to normalize the documents before we create an embedding for them. This makes all the documents have a similar style, and the embedder is more likely to place the related documents closer in the vector space. To do the normalization, I use the following prompt. Serverpod is an open source backend framework for Flutter developers written in Dart. This is a page from the documentation. Please write a brief summary of this page. Be sure to mention Serverpod and Flutter and make sure to include any key concepts mentioned in the page. The page follows here. After the prompt, I include the full documentation page. The prompt ensures that we also mention Flutter and Serverpod in the summary. This also helps with creating a good embedding. It's really easy to send the prompt and the message to Gemini using the Google Generative AI package. First, set up the generative model object with the model you want to use and the API key. You can get the API key from Google, and the free tier is pretty generous. Then call the generate content method on the model. Gemini will return the full reply as a future string, so we just have to await that to get the answer. Now that we have the normalized document, we create an embedding for it. We need to use an embedding model for that. The embedding models are different from the ones that we normally use. Instead of outputting texts, they will give us a vector of numbers. We create a new generative model object and pick one of Gemini's embedding models. Now, we can call the embed content method to retrieve the vector. Sweet! Now we have our documentation text as markdown, a summary, and a vector embedding. Let's look at how we can store this in the database. Serverpod comes with an ORM, or object relation mapping, to talk with the database. You create models in YAML files and run the serverpod generate command. This will create Dart code with both support for serialization and connections to the database. Let's look at the model for the RAG document. First, we define the class name and the name of the database table. Then we add the fields we want in our model and the Dart type of the fields. In addition to the content, summary, and embedding, which is the vector we got from the model, we want a source URL and the time we fetched the document. It's useful to keep track of the time to avoid reprocessing recently added documents. This way, we can save on the number of requests we send to Gemini. If the database contains a large number of documents, searching can be slow. To improve the speed of the searches, we add indexes to the database table. The indexes can also enforce consistency in the database by requiring that a specific field is never repeated. Let's add 2 indexes to the RAG document table. First, we add the RAG document source URL index. We make it unique. This ensures that we can never store 2 different objects in the database with the same source URL. Next, we add an index for the vector embedding. There are different types of indexes we can use for vectors, but for searching text, HNSW with a cosine distance function is a good choice. To make the model accessible in Dart, we use the serverpod generate command. As we have added a new table to our database, we also need to create a migration. A database migration is basically a set of SQL queries that updates the structure of the database. It can be adding new tables, fields, or indexes. We create the migration by running serverpod create migration. Now we have everything we need to store our RAG document in the database. We use Serverpod's ORM for this. To access the database, we need a session object. A session is passed to our future call, but we can also create a new session by querying our Serverpod instance. However, remember that if you create a session, you are also responsible for closing it when you're done. Our RAG document model has a static field called DB, which gives us access to the database. Here, we can find methods for searching the database, inserting new objects, or updating existing ones. Let's create a new RAG document object and insert it into the database. We use the RAG document.db.insertRow method to insert our object into the database. Easy as that. Let's take a step back and look at what we have so far. We are pulling documentation pages from GitHub. We're summarizing them to get a normalized text, which we pass to the LLM to generate a vector embedding. Finally, we insert all these elements into our database together with the current time and the source URL of the documentation page. Next, we need a way to search all these documentation pages, pick out the most relevant ones, and generate an answer to a user's question based on the documentation we provide. Ideally, we want to stream the response text back to the Flutter app as soon as it becomes available. To do this, first we need a way for our Flutter app to connect to our server and receive a response. If we're using Serverpod, this part is really easy. In our server package, we create a class that extends the endpoint class. This will make it possible for Serverpod to find this class and generate client code for us to use in our Flutter app. Let's call our endpoint starguide endpoint. Next, we can add methods to our endpoint. The method can either return a future or a stream, and its first parameter must be a session object. After that, we can pass any basic Dart types or serializable objects as parameters to the method. Let's create a method called ask. It will return a stream of strings. These will be the string segments we get back from the LLM model as they become available. For the first parameter, we have the session object. Then we add the second parameter with the question we want to ask. We will use the question to generate an embedding, which we can use to find relevant documents from the database. But just like when we process the documents, it's a good idea to normalize the question to look as similar as possible to the texts that we use to create the embeddings for our documentation. To do the normalization, we use a pretty clever prompt. We ask the LLM what it thinks a summary of the Serverpod documentation would look like for the question. This is the prompt. Serverpod is an open source backend framework for Flutter developers written in Dart. Please rewrite the following question in a way that a summarized Serverpod manual page would likely phrase it, focusing on key terms. Make sure to include the terms Serverpod and Flutter. This is the question. After the prompt, we include the user's question before passing it on to Gemini. Now, we will have something that we might find in the documentation. The next step is to take our fake, imagined answer and pass it to the embedding model. This will give us a relevant vector for the user's question. When we have the vector, we can search our database for documents related to our user's question. This will give us relevant documents, even if the user may be using words other than what we have in our documentation. Pretty cool! So, how do we do this with Serverpod? Luckily, the ORM Serverpod provides makes searches like this really simple. We use the RAG document.db.find method to do a search. Then we order the results based on the proximity to the embedding for our question. Finally, we set a limit for the number of documents we want to retrieve. Otherwise, the whole database will come back, which can be a lot of data. The database search gave us the top 5 documentation pages most likely relevant to our user's question. All we have to do now is send a final query to Gemini, which includes a prompt, the relevant documents, and the user's question. By default, Gemini will give us a response formatted in Markdown back. This is great, as it's easy to display nicely in our app, including any code samples, bullet points, and headlines. Markdown also makes it possible to stream the response back. In our prompt, we can ask Gemini to format the response in a certain way and to give us references to relevant documents. The prompt I used is rather long, so I will not include the full one here, but to get the reference at the end of the response, I used something like this. At the end of the response, provide sources for the documents referenced in our answer. Only include references that are relevant to our answer. First, make a headline called #references, then add markdown links one line at a time. Gemini is good at following these instructions, so we can parse this information in our Flutter code to do some nice formatting for the references. Right, let's pass our prompt, the relevant documents, and the user's question on to Gemini. The Gemini model has a generate content stream method, which will give us a stream of updates back. What's really neat is that Serverpod lets us pipe the updates back to our Flutter app. We just take the stream we get from Gemini and map it to a stream of strings. Now, we can just return that stream. Another typical way to return messages on the stream is to use the async star keyword for the method and yield the messages one by one. I'm not going to touch on any of the Flutter code for this talk, but let's have a look at how we can call our method from our app. To connect to a Serverpod server, we need a client object. The client is automatically generated for us when we run Serverpod generate. So we can just create a new client by passing in the name of the host we're connecting to. As we're using real-time communication, it's also a good idea to set up a connectivity monitor. It will monitor the status of our internet connection so that we can quickly see if we get disconnected. Once we have the client set up, we can use it to access our ask method on the server. We call it by referencing our starguide endpoint. So just call client.starguide.ask and pass in our question. We will receive a stream of strings back containing our answer. We will get the parts of the answer as soon as they become available. Under the hood, Serverpod will use a WebSocket to pass the data for us, but we don't have to worry about that too much. Serverpod will automatically manage the life cycle of the connection and route the messages to the right place, both in our app and in the server. How sweet is that? With a little bit of Flutter code, our app will look like this. Of course, the code samples I showed today don't make up the full app, but it's all open source and you can find the complete project at github.com/serverpod/starguide. Let's wrap things up. Today, we've seen how powerful it can be to build with LLMs in your Flutter apps. We started with a simple question: what if you can chat with your documentation? And we ended up building starguide, a real-time AI assistant that pulls answers from real documentation, all through a smooth and responsive chat interface. You have seen how Serverpod makes it possible to stay in Dart from top to bottom. From your Flutter UI to your AI backend, everything speaks the same language. You don't need to bounce between tool chains or write glue code. It just works. You've learned how RAG turns LLM from a general purpose model into a domain expert, and how embeddings let us search by meaning, not just by matching words. And how you can use Gemini with Serverpod to stream answers back to your app in real time. So, what can you build with this? That's up to you. Whether it's a customer support, code assistance, education, internal tools, if you have knowledge in documents, you can make it chat. AI isn't just a magic trick. With the right architecture, it becomes a practical and scalable part of your app. And now you've seen how to make that happen. Thanks for watching. I hope I've inspired you to try out Serverpod and explore the starguide code. And if you build something cool, share it. I'd love to see what you come up with. You can follow me on LinkedIn, Victor Lidholt, on X or on Blue Sky, and you'll find everything about Serverpod on our webpage, serverpod.dev. Until next time, happy coding!